Good morning, it's me, Mr. Truman. We're back for round 2 of similarity and right triangles. Our first video I went over basically just kind of the basics of how to separate the triangles, how to write the statement, kind of show the proportions. And in this video, part 2, we're going to look at application of doing this and actually just solve 4 different problems that are rather difficult, if you will, because you have to really have a good visual spatial sense of what's happening. And that's why hopefully that little drawing the triangles apart thing in the previous video will help you out. So the first term I want to go over with you that we don't talk a whole lot about, but is actually what we're doing in several of these problems, is called geometric mean. And if we think about mean generally stands for average, but normally when we find average, we add everything up and we divide by however many. That's the average. That's arithmetic mean. Geometric mean is when we multiply two numbers and find the mean of the product. So I'll show you that in a moment. So jumping right in, we'll look at example number 1. It says find a geometric mean of 9 and 16. Well, the way we write that when we want to figure this out is we go like this. We say x is to 9 as 16 is to x. And so when we find a geometric mean, we basically write it as x over a number equals another number over x. And when we cross multiply, what we're going to end up with is x squared, because x times x, equals 144. And what we're going to do here is, to solve this, we're going to take the square root, and we're going to say x is equal to 12. Now, sometimes you end up with really large numbers when you do this, and so one of the things I can say, a little trick to this is, sometimes like when you know what you're going to be doing is finding the square root, you could just write it like this. And then look at those two numbers. Before you make them gigantic numbers, look at them two and say, all right, I know I'm going to be finding the square root. So come down a notch and just write like this, square root 9, square root 16, in which case I will then know, I'll just say 3 times 4, which is 12. It looks like a little bit more work, but sometimes, like I said, when you multiply these two numbers, you end up with a really big number in the thousands, and it's really hard to figure it out because nobody really knows their square roots past about 12. So if you end up with a number like 3,000 and something, you're not going to be able to figure it out easily. So just take the step of saying, all right, I know I'm going to be finding the square root. Just write them in smaller numbers first. All right, so let's look at a problem that involves geometric mean. We're going to jump right in with number 2. This problem is going to have geometric mean. It's actually going to be kind of the same as the one I got above it, and I did that on purpose. So when I look at this problem, the first thing I notice is, I didn't put this line here, which drives me nuts. But I notice the whole thing is 25, and this part's 9. So whenever I have information like that, I always want to jump on that and figure out, hey, if this is 25, and this is 9, this has got to be 16, because 25 minus 9 is 16. Now, I need to solve for x. Well, x is being shared by the smaller triangle here and the larger, or medium-sized triangle, if you will, right here. Well, I notice on the small triangle, this is my short leg, and this is my long leg. But on the one here in the middle, the medium one, this is the short leg, and this is the long leg. These things are related, so I can use this triangle and this triangle. If I put them together, I can figure out the answer. So the way I'm going to do this is I'm going to go like this. Short leg over long leg. So short leg over long leg equals short leg over long leg. And we end up with something called geometric mean. Now the reason we don't use the 25 in this problem, and I want to make sure that you understand why the 25 was not used, is because the 25 represents the hypotenuse of the largest triangle, the one on the outside, and I don't know any numbers on the outside of that triangle. I don't have any other information, which kind of tells me that using the big triangle is not going to be the one I want to go with, because I only know one thing about it, that its hypotenuse is 25. I don't know its short leg, and I don't know its long leg. Therefore, I know that it's probably not the way to go. Now back to this problem, like I said, we're going to do our square roots. X times x is x squared. 9 times 16, I could end up with a big number, but we know it's 144. x is equal to 12. So again, I applied what's called geometric mean, and that just came out because of the fact that the way the numbers laid out on this problem, I ended up with x squared. All right, the next problem, a little bit different, but you're gonna wanna do the same thing, but you're gonna realize, wait a minute, that doesn't do anything for me. So seeing that it's 81, I am gonna write down the information, even though I'm gonna show you why I don't use it. So 81 minus 45 tells me this part right here is 36. Now, I need to figure out a way to solve for x. And when I look at it, one of the things I'm looking at is when I look at this little triangle, this smallest one, the only thing I know about it is the short leg. I don't know its long leg, and I don't know its hypotenuse. It's kind of telling me that it's not going to be part of the problem. When I look at the medium-sized triangle right here, I have its hypotenuse, and I have its long leg. So I've got two pieces of information, and then when I look at the big picture as a whole, this big one, I notice I have its hypotenuse, 81, and its long leg. So I have some information there. I've got a hypotenuse and a long leg, a hypotenuse and a long leg. So I'm going to go ahead and start my problem. I'm going to start off with x over 45, x being, in this case, the long leg for this triangle, or the hypotenuse for this triangle, 45 the long leg. Now I need another hypotenuse, that's 81 over x. Well, I got to do the whole geometric mean here. I've got to say x times x is x squared. And I have no idea what 45 times 81 is, but I'm going to bet it's a large number. So instead of going down that road, I'm not going to. I'm going to just write 45 times 81. Because I know that I'm about to take the square root anyways. So by leaving them in smaller pieces, when I go to the next step and I take the square root, I end up with x. Now I have to find these two square roots. Well, that's kind of easy because 81 is 9. I just got to come over here to the side and figure out what's the square root of 45. Well, 45 is 9 times 5, and the square root of 9 is 3. Cross it off, and all I'm left with is radical 5. So now when I work it out, I end up with 27 square roots of 5. This is probably the highest end or most difficult application of this particular thing, but of right triangles and similarity. But it is doable, and we have practice. We spent a whole class period just working on how to reduce a radical. Which brings us to this last and final mess of a problem. This thing is terrible looking at first, but if we break it down and I show you a little bit about algebra 2, a little algebra 2 lesson on radicals, I think we'll be all right. So looking at this one, here's what I see. I'm going to take inventory. I'm going to look at this medium-sized triangle right here. I have its hypotenuse. In case you don't see it, I have its hypotenuse, and I have its long leg. So hypotenuse, long leg. I'm going to write that down. 50 radical 3 over 75, hypotenuse, long leg. Now, when I look at the big triangle, not the little one, because again, when I look at this little one, I notice I got a blank spot and a blank spot. That's 2 for 2 on not giving me any information. Not going to go that road. But I look at the big one. On the big one, I have the hypotenuse, and I forgot to write this here. I have the hypotenuse. I have the long leg. So when I write it out, my hypotenuse is going to be 75 plus x. And my long leg, in this case, is 50 square root of 3. All right, so again, I'm going to go down a little bit of an algebra 2 lesson, but make sure you can do this problem for next year. All right, when you go to multiply this out, I'm going to start with the easy part first. 75 times 75, and I don't even know that either, so. Oh, big numbers here. 5,625. 75 times x, 75x. So I've done this part. Now when I come over here, this is probably looking very intimidating to you, but remember, we did this before. 50 times 50 is 2,500. And we talked about this in class. What is the radical 3 times the radical 3? it's 3. 2 roots make a whole. So when I bring that down a notch, I've got 5625 plus 75x equals 7,500. And then it goes right down into being an Algebra 1 problem. All you gotta do is say 7,500 minus 5,625. Double check that's right. 7,500 minus 5,625. And then I divide by 75. X ends up being 25. The missing number right there is now 25. All right, I hope that what I did here is showing you a little bit of how to work these out. I know this is a tough situation where every problem's different, but I hope this works for you. Bye-bye.